conversion of decimal numbers into the rational number of the form p by q. We already discussed two cases. Case 1 about terminating decimals. With the help of power 10 in the denominator, we can convert terminating decimal into the form of p by q. Case 2 we have discussed pure repeating decimal. Pure repeating means after the decimal point, digit or block started repeating. That is known as pure repeating decimal. To convert that pure repeating decimal into p by q form, we have these four steps that we already discussed. Now we will discuss case 3, general repeating decimals. A general repeating decimal has some non-repeating digits just after the decimal point, followed by a repeating block. For example, 0.16 bar, 0.3571 bar. These are the example of general repeating decimals. In this example 0.16 bar, after decimal there is a one non-repeating digit and then after 6 started repeating. Same here in this example 0.3571 bar. After two non-repeating digits that are 3 and 5, 7 and 1, this block started repeating. Now how to convert general repeating decimals into the form of p by q? We have these 5 steps. Let's discuss. First we are assuming x as a decimal number. Whatever given number, that we have to assume as x. Now second step, multiply by 10 raised to m, where m is equal to number of non-repeating digits. So as in this example 0.16 bar, we are assuming x as 0.16 bar and we are multiplying by 10 because here only single digit is repeating. So multiply by 10 raised to m. Here m is what? Number of non-repeating digits. This gives equation 1. Step 3. Then multiply the result by 10 raised to n. Whatever equation 1 we have obtained, here we have to multiply by 10 raised to n, where n is number of repeating digits. For example, in this 0.16 bar, to obtain equation 1 in step 2, we have to multiply by 10 because there is a only one non-repeating digit. And in step 3, to obtain equation 2, again we have to multiply by 10 because only one repeating digit. Step 4, subtract equation 1 from equation 2. As earlier cases, we have to subtract equation 1 from equation 2, which gives in step 5 equation for x. After solving, we will get equation for x. So these are the 5 steps. Let's have an example. Convert 0.16 bar into the form of p by q. So first we have to identify which decimal number is this, whether it is pure repeating or general repeating. So this is a general repeating because after decimal point there is one non-repeated digit. So this is a general repeating decimal. So according to first step, we are assuming x as a 0.16 bar. Now here one digit is repeated and one digit is non-repeated. So here one repeated only one time. So we have to multiply x equal to 0.16 bar by 10. So we get 10x is equal to 0.6 bar. We'll call this as equation 1. Now 6 bar repeating digit. We have to multiply equation 1 by 10. So 10 into 10, 100x, and 10 into 1.6 bar, which is equal to 16.6 bar, which is equation 2. Now subtracting equation 1 from 2, 100x minus 10x is equal to 16.6 bar minus 1.6 bar. So 100x minus 10x, 90x, 16 minus 6 bar minus 1.6 bar, 6 bar 0, 16 minus 1, 15. So x is equal to 15 upon 19. Now 15 ones are 15, 15 6 are 90. So x is equal to 1 by 6. What we assume x? 0.16 bar. So therefore the decimal number 0.16 bar is equal to 1 by 6, which is a required answer. Next example, convert 2.4537 bar into the form p by q. In this decimal number, two digits are repeating and two digits are not repeating. So we have to assume first x is equal to 2.45 bar 37. Since two digits are not repeating, we have to multiply it by 10 raised to 2. So 10 raised to 2 is 100. 100 into x, 100x is equal to 245 point bar 37. After multiplying by 100 to this number, decimal will shift by 2 places. We got equation 3. 100x equal to 245 point bar 37. Now since two digits are repeating after decimal, so we have to again multiply by 3. 10 raised to 2, that is 100. So we get 100 into 100, which is equal to 10,000 x. 100 into 245 point bar 37, which is equal to 245.37.37 bar, which is equation 4. Finally, we got equation 3 and equation 4. Subtracting equation 3 from 4, we get 10,000x minus 100x is equal to 24,537 point bar 37 minus 245 point bar 37, which is equal to 10,000 minus 100x, 9,900x, and this subtraction is equal to 24,292. So x is equal to 24,292 upon 9,900, which is equal to, whose conversion form is 6,073 upon 2,475. So therefore 2.45 bar 37 is equal to 6,073 upon 2,475, which is a required form of P by Q. Till now we have discussed decimal expansion of rational number P by Q. Decimal expansion is basically divided in two forms, either terminating decimal or repeating decimal. Repeating decimal means which, for example 0.23 bar. Here the block of digits 2 and 3 is repeating, and terminating, for example 0.25. This is a terminating decimal expansion. Now repeating decimal expansion further categorized in two parts: pure repeating decimal, general repeating decimal. So pure repeating decimal means after decimal the block of digits suddenly started repeating. So for example 0.1 bar, 0.72 bar. Okay, and general repeating decimal expansion means after the decimal there exists one or two or more non-repeated digit, and then after sequence of digits or digits started repeating. So such examples are 0.12 bar 7, 0.352 bar. This is a general repeating decimal. This is a decimal expansion. These are the types related with a rational number. Then question may arise is, what about decimal expansion of irrational numbers? So think and reflect. The decimal expansion of rational number is either terminating or repeating. So just now we discussed this. The decimal expansion of irrational number is non-terminating, non-repeating. For example, root 2 is equal to 1.41412356237309504888 and so on. Pi is equal to 3.141596535897932384 and so on. So root 2 is also irrational number, pi is also irrational number. If you observe decimal expansion of root 2, there is no sequence of digits to be repeated. There is no block of digits to be repeated. No digit is repeating here. in any of the pattern. Here also no sequence or no block of digits is repeating. So irrational number has non-terminating, non-repeating decimal expansion, whereas decimal expansion of rational numbers is either terminating or repeating. Next, the magic of cyclic numbers. Decimal expansion of 1 by 7 is 0.142857. Here is 1, 142857, and so on. So here decimal expansion of 1 by 7 is 0.142857. So block of 6 digits started repeating. If we multiply it by 1, 2, 3, 4, 5, 6, then what will happen? 0.142857 multiplied by 1, 0.142857. If we multiply by 2, then we'll get 0.285714. If we multiply this by 3, then we'll get 0.428571. If we multiply by 4, then we'll get 0.571428. If we multiply by 5, then we'll get 0.7142857. Sorry, 0.714285. And if we multiply by 6, then we'll get 0.857142. What we observe here? Here we can observe after multiplying 0.142857 by 1, 2, 3, 4, 5, 6, we have observed that the digits 1, 2, 4, 5, 7 and 8 in the block are rotating. So this number we call as a cyclic number, and such block is cyclic. So here we observe that the digits 1, 2, 4, 5, 7 and 8 in the block are rotating. So this number we call as a cyclic number, and such block is a cyclic block. Okay, thank you.